Thanks everyone for coming. I'm really curious where everyone is dialing in from today. So if anyone wants to share in the chat where they're coming in from, I'd love to know kind of what areas, what countries, what cities people might be coming in and listening. Started. So while people are kind of filling out where they're from. My name is Mike. I was formerly the co-founder and CEO of HyperDX. We were a startup building on top of ClickHouse for observability in the open source world for a number of years. And earlier this year, we were acquired by ClickHouse, and now I'm here leading the observability product efforts. So really excited to be sharing with everyone what we're working on here at ClickHouse, our vision ahead, some of the improvements that we've been making, and answering the questions that you guys have about what we're doing at the end of it. So today, talking about ClickHouse for observability. Before diving in further, ClickHouse is of course, widely adopted for observability for some of the largest use cases at companies like Anthropic, Tesla, OpenAI, and many, many more companies. This is just a subset of the companies that are actually adopting ClickHouse specifically around observability. If you're more interested about how these companies are using ClickHouse and more details about it, we'll have more information to send out later. They've all came and spoke at our user conference or meetups in the past, or written share their use cases online as well. So you kind of understand a little bit more deeper about how they're leveraging ClickHouse to power their observability platforms, how it scales a lot better than before. And I can certainly say that some of these folks have migrated from the tools that were kind of shared on the poll just earlier. So super great content from a lot of these great users and customer of ours. But diving into a bit of why they kind of ended up with ClickHouse as their observability platform, I actually want to take a recap of kind of how we got here in the first place and a bit of history of how we've been treating observability data in general, right? And really from the very beginning, I would say like grep is maybe one of the earliest observability tools per se. Like the humble grep are able to search your logs on top of any single server at any given time, so you can find a specific error message or a specific ID to go figure out what's going wrong with your program on a single server. And over time, as observability got more complicated, you have more servers, more logs, you'll have the ability to actually, or the need to actually centralize all these logs into a central place. And that's where Splunk really came around, the ability to centralize logs onto a single Splunk server, and you can search across many different files all at the same time at what was at the time a relatively cost-effective solution, given how little logs were at the time compared to now. And evolving further, that evolved into Elasticsearch and Elastic Stack, where again there was an increasing need to provide searching on a higher volume of log data. But eventually, we got to the point where it wasn't enough to just find a specific error message, a specific log, what went wrong. We actually needed the ability to see trends over time to understand, out of our fleet of servers, is there a set of servers that are misbehaving? Is there a region that is misbehaving? We needed to get a lot more high level view of trends over time as opposed to being able to do individual searches. And it turns out all these search engines that have been built so far are not really fantastic at it. They could kind of do it, but they don't really scale to the kind of demands at the time. And that's where we get databases that are more metrics oriented or time series oriented around Graphite in the beginning. And then, we got more servers, more complexity around metrics, more cloud nativeness. So things kept scaling in and out. So you had Prometheus, which had, better support for higher cardinality, more dynamic environments with their labels. And then, later on, tools like Thanos and many other, metrics data sources as well that continue to try to solve the problem of you have too many metrics to sit on a single server in Prometheus. We need to scale out with Thanos as well. But the problem basically was every time there's an increase in volume, an increase in cardinality, we needed a new solution to be able to tackle it. And but the whole time we were still making trade-offs between all these different tools. Effectively, on one side, we had search engines. It's not like we ever got rid of Elastic in favor of Prometheus or Thanos. We still kept it there because it was still really good at doing that needle in the haystack query to be able to say, hey, I have a specific error I'm looking for. Those search engines are really great at finding it. But again, they kind of lack the ability to zoom out and get the higher level trends of what was happening in your application. And on the flip side, when we switch to metric stores to help basically augment the story, um, they were really built for, just for pre-aggregating data. That meant that you could get trends over time really quickly, but you couldn't really dive down to the original event that triggered an error, for example. You lost that root cause, and there's no ability to link between a rising count in errors and what specific error messages were happening at that given point in time. So effectively, you always had to choose between something that was fast at searching but couldn't give you trends, and something great at giving trends but weren't great at searching. And the engineer at the end of the day had to kind of correlate the two manually and fill in the gaps between those two pieces. But is there a world where we could have our cake and eat it too, where we don't have to make these trade-offs between a system that is great at doing search, a system that's great at doing aggregations, and a system that is also really important these days, cost-effective as well? We have this great, object storage idea or product available in the cloud, and provides really cheap storage. It's effectively infinite as well, or bottomless as well. And it'd be really great if we had a data store that could leverage those properties. And it turns out there is. ClickHouse is a really fantastic database for observability because it's a high performance columnar database. It has the ability to have these lightweight indexes for search. So you're still able to do needle in the haystack queries with ClickHouse, but without the cost of really heavy search indices that take forever to build and take a ton of storage. It also is really great aggregations because of its columnar nature. It's able to aggregate across billions or more events incredibly quickly on the fly without requiring low cardinality pre-aggregated metrics like you might need for an existing metric store. And additionally, ClickHouse is built to leverage cheap object storage. So it allows for infinite storage and retention at a very cost-effective price point. So for those that aren't familiar, ClickHouse is a really fantastic database for observability in general. It has a ton of features that makes it incredibly well suited for it. It's built to handle petabytes of data with real-time results for both queries and ingest, so it doesn't choke just because you have a large volume of data to write. It does this by being incredibly resource efficient with high compression ratios, and also the concept of compute and storage isolation, as well as compute and compute isolation that allows for a smaller hardware footprints and easier scaling as your system increases load over time. And it also allows for schemaless data. So you can dump in kind of very common in your observability use case. You have your semi-structured JSON data. Your developers might be writing any kind of arbitrary sets of properties into your database. ClickHouse supports that as well and allows you to still query it as if it was in a semi-structured manner. It's also incredibly flexible due to it being anti-SQL compatible. So it's a full SQL database. It's really easy to query data out of it, and it's really powerful to answer any questions that you might have. And it's also compatible with a wide variety of telemetry shippers, such as OpenTelemetry. And finally, ClickHouse is interoperable with a wide variety of storage standards. So whether you have your data stored in ClickHouse's native format, or if it's in a data lake like a Parquet, Delta, or Iceberg, or other formats on disk or in object storage, ClickHouse can work with it. And really, to make it really easy to get started and leverage ClickHouse as part of your observability stack, we released ClickStack. So ClickStack is the high performance open source observability stack powered by HyperDX, ClickHouse, and OpenTelemetry. So it's a stack that we fully maintain here in-house here at ClickHouse. So you're getting the best of leveraging ClickHouse's capabilities for observability. It's really easy to get started. You can deploy it in seconds on top of either an existing ClickHouse instance. So for those folks that came in on the poll and said that you're already using ClickHouse for observability, that's really fantastic. You actually adopt ClickStack on top of your existing ClickHouse database and existing telemetry pipelines into ClickHouse on top of any schema. So it doesn't have to require a specific schema that only works with ClickStack. It's quite flexible to any schema. But on top of that, it also, of course, allows you to deploy on a new ClickHouse instance really easily too. So if you're part of the folks that weren't using ClickHouse already, it's really easy to get started with ClickStack as well. The whole stack is really purpose-built for observability. So, and it's able to monitor anything from front-end events, so session replays and client-side events from the browser, all the way back to your logs, metrics, and traces, and of course, your infrastructure metrics as well. And the last part is, of course, open source is at the core of everything that we do, and ClickStack is, of course, no exception. So the entire stack is completely open source, so you can deploy and run the stack anywhere. Um, and with that, that's a lot of slides so far. So I'd love to just dive into a quick live demo to see what it's like. So the first thing I want to show is basically how easy it is to get started with ClickStack. So I'm going to share my terminal really quick. So basically, we have an all-in-one image that will spit up everything as part of ClickStack in a single image. This might not be what you want to deploy to production, but certainly it's really useful just to play around locally. You just hit Docker run. Usually there's a few more port forwards you want to have available. You could check out the documentation, which we'll link later. But with that, your stack is started. You can visit the UI and get started playing around with using ClickHouse for telemetry. With that, let me switch over to my browser where we could actually start poking around at some of this telemetry as well. So here is the landing page. You can kind of see the logs coming by here. So we have our logs are streaming by constantly. So this is probably a familiar interface for most of you who've kind of written down you're using one of these existing tools in the market. One of the favorite things I like to show off is a use case around being able to understand a rising error rate or a rising number of errors that are happening in your system. Sometimes your colleague might come to you and ask you, hey, we're having an increase in errors recently. Can you help investigate what's actually going on and if there's anything concerning for us? So we can really easily, select the error filter here. Let's go back 12 hours, maybe started, a few hours ago, and we want to understand the overall trends. And we can definitely see that this is true. There's indeed a large rise in errors recently. And what we can actually do is we can really easily hit the event patterns button. And what this will do is it'll start analyzing the different patterns of logs that were happening in your system, and it'll start grouping together similar logs together. So even if you have a bunch of noisy logs that are pretty similar, it'll group them together into one place. So in this case, we can definitely see that there is a rise, and here the patterns also showed as well. There seems to be some fail to place order log that's happening, and you can see some other fail to charge card messages, and one message that's really interesting to us that there's some cache. The cache is full. So this seems pretty correlated with what we're seeing up here, a huge spike. At the same time, we're also seeing a huge spike here. And this is probably the most descriptive error message. So let's go click into this log to learn a little bit more. And we'll click into a specific example of this log. So here, when we get a log within the UI, by itself, it's not super helpful. But because we're storing different types of telemetry into ClickHouse, we can actually pivot from the log message into the traces, where we might have a bit more rich context as to what's happening in our application. So the first thing that we know is that we're able to actually trace down where this request came from. So this is a demo sandbox, so it's coming from a load generator. But in real life, this might be coming from a browser. You could go view the user session more specifically. But going down kind of the stack, we can see that there is this error here. And very helpfully, we also have a error span. And in this application, we actually happen to enrich the error span with source information. So we can not only understand the exception that was thrown and the message, but also understand a bit more about the sources surrounding it. This isn't available all the time, but in this specific case, we instrumented the SDK with the original source maps. So understand this is where in the code that I threw. And then also, just in case, we think that, hey, maybe it might be infrastructure related. Again, because we're sending all our information to ClickHouse and we're correlating all in a single place, we could really easily pivot from this log message to the infrastructure metrics associated with it. So you can see things like, hey, is the pod misbehaving? Does it have excess CPU usage, memory usage, or disk issues? In this case, nothing was happening. Was there any abnormal pod events? Like, was the pod being killed rapidly in the past? Or having some other issue in the past as well. Nothing here. And then, of course, we could take a look at the node metrics as well to understand, well, was the node misbehaving? Did it have a spike in CPU usage? Were we running CPU contention, memory pressure, et cetera, et cetera? And again, here you can see that there wasn't really any issue that we ran into here. So that's just one of the workflows that you can see within ClickStack. But honestly, there's a lot more that you can do as well. So another one that I probably won't have time to step through live, but might be interesting is, for example, the event deltas use case as well. So this is a feature where if you send your traces into ClickHouse and ClickStack, we're able to help you visualize outliers of your data set. So what I did here, what I have here is basically a heat map of all the events that are happening in your system, all the spans that are being sent into ClickHouse. I'm visualizing how long each of them are taking. I'm able to highlight a outlier set of data to say, hey, this is an outlier compared to everything here. This is taking a lot longer than we expected, which is out of the norm. And basically, we'll get in return what properties are correlated with these outliers. So in this case, we're seeing that there is all these outliers are being correlated with a span name of place order and a span name of HTTP post. And we can look through the other properties as well to see what other properties might be correlated with this outlier. But it gives us the ability to go from, hey, we have a massive slowdown in a set of operations to knowing, hey, here are the specific attributes that are correlated with the slowdown compared to all the regular behaving requests as well. So it gives you the ability to quickly do, deltas or differences between the events that you're seeing within ClickHouse. So that's just a really brief demo of some of the features. Happy to talk more about them later. But with that, I'd love to return back into the slides to talk about some of the work that we've been working on specifically on top of the product. And with that, yeah, so love to cover kind of what is new within ClickStack and what are some of the most recent changes. One of the more exciting ones that we've shipped out recently, and one of the biggest ones certainly, is the new JSON data type and support for it. So basically, for those that have been using ClickHouse before, ClickHouse used to have this data type called the map data type. It allows you to store arbitrary key value pairs. So this is really useful if you're using wide events and you're storing a lot of structured logging or a lot of structured information inside your telemetry. We had a map data type, so you don't have to specify every single property at a time in the schema. While this data type was incredibly useful, it had some shortcoming at the end of the day. One of the biggest ones is really that the map data type wasted a lot of I/O when it came to reading. So basically, even though if you need to read just a single property out of your logs table, for example, the map data type will still read a significant amount of the actual entire map column, so all the key values or all the keys effectively, before able to return the value to you. And this added a lot of I/O overhead, it slowed down query by a bit, and to get around this, it's really popular to manually manage the columns within the map data type. There's basically a bit more work to make it the most performant as possible. And another issue with the map data type is a loss of precision. So in our old schema, as you might have noticed, this is a map from string to string. This meant that we basically just casted all the data into string data types. This loss, introduced a loss of precision and also led to a bit more work as the database had to cast from strings to, floats or ints, depending on what you're trying to do. So if you're trying to sum a specific attribute, we had to cast it back before we could actually use it. And then the last bit is also there wasn't, the concept of native nesting. So there was a lot of like flattening that was required before you can add data into ClickHouse. Certainly something you could do within your observability pipeline but it was just one extra step the users had to do to get things working. So now on top of ClickHouse, there's a new data type called JSON. It provides performance as if it was a structured, defined schema, predefined schema, while giving you the flexibility of adding arbitrary attributes. And at the end of the day, it's really the biggest gain is around performance. It's incredibly fast because it is keeping the native data types within the columns as they were kind of written to it. So if you gave it an integer, for example, store as an integer, not a string, which of course saves a lot of bytes and keeps it a lot more performant. It handles nested data structures really easily as well. So if you have like a deeply nested field, it also works with that out of the box. You don't have to flatten it ahead of time. And also another thing as well is that the JSON data type automatically manages all the properties that are being written to it. So for the properties that are the most important, it'll optimize it to be read really quickly by turning it into a specific column. And for properties that are a long tail end, it'll put it into a bigger bucket of columns so that it won't lead to performance degradation by having a ton of different columns for properties that aren't used very often. And this is just diving a little bit deeper into how the JSON data type works and kind of talking a bit towards what I was mentioning earlier. So every time you write a attribute and a value into ClickHouse, it will store it into its own column. And here, this is demonstrating how every single data type gets its own specific column. So for example, even if you have a property that has multiple different types, so this definitely affects certain systems where you have a property type collision effectively. ClickHouse handles this really well because we'll take a look at what the data type is and actually store it into its own individual column. So we're able to handle property type conflicts. And also, this gives the ability of ClickHouse to really optimize that specific type. So all the integers are put in the same way, column, all the floats are put in the same column, et cetera, et cetera. So that helps kind of preserve performance and allows for a really fast experience on top of ClickHouse, even for semi-structured events. And very common people ask, well, what happens if I have a ton of different columns? I might have thousands or tens of thousands of properties. It'd be really difficult to turn each of those into a column in ClickHouse. Like there's a bit of overhead associated with every single column. So that's kind of where the intelligence of the JSON type comes in. It will figure out what are the properties that are used the most often, and then put them into its own specific column, and it'll look at properties that are used less often, and it'll be put into a shared data column. And that is going to keep your database really performant for all the most common properties, while also not, completely exploding the amount of columns that are being created just because there's, a really high cardinality set of keys within your data. So again, really handles that high cardinality case really well. And there's also a lot of other things the team has been working on in terms of performance optimizations. So there's a lot of small optimizations. This is a quick demo in one of the ones that we've done recently, where we really help optimize the order of which ClickHouse is scanning data, basically always allowing ClickHouse to take advantage of the timestamp ordering of your data. So usually you're looking for perhaps your oldest data first, or the newest data first. Either way, you're usually looking for some sort of bias in the ordering. We've added an optimization that allows ClickHouse to basically scan data in order and prefer an in order scan. So here, the original naive query might have taken 1.9 seconds. Here, the faster query only took a fraction, a small fraction of a second, and that's being applied automatically within ClickStack now. Another small optimization here as well is basically the ability to take a query that's being written over a long time range and actually chunk them into smaller time ranges to be able to search them asynchronously. So this basically, if you're asking for a 30-day search, if a 7-day search, for example, it's really inefficient to look over the entire date range all at once without having kind of a priority over what part of the date range to focus on. So again, this allows us to drive the database to be able to focus on, hey, like we're only looking for usually either the most latest data or perhaps the oldest data, and to be able to prioritize the order of which we return data back from the database. And this again just really helps performance and dramatically speeds up the time to results that you get on top of ClickHouse using ClickStack. And one of the most exciting kind of big product improvements we made as well is having that ClickStack integration onto ClickHouse Cloud. So if you're using ClickHouse Cloud today for any use case, basically, especially observability, now you can use the ClickStack integration to launch an observability native experience directly on your ClickHouse Cloud account. The authentication is seamlessly tied to your existing ClickHouse Cloud identity, so you don't have to create a new account, a new app, host anything separate. You basically just open the ClickStack integration, and all your teammates can do as well, and they can get that observability experience on top of ClickHouse Cloud. There's no additional, manual connection configuration required, and it's currently available in private preview at no additional cost. And we'll send a bit more information later on, and happy to share more about it as well if there's any questions about it. But that is available for folks to try out today as part of the private preview. And obviously, the team has been incredibly busy. There's no way I could fit all the changes that we've making to the application. Um, but here are some of the more exciting ones around custom collector configuration, exporting data sets of CSV, auto correlating sources, inverted index support. So that's a really exciting improvement to ClickHouse as well. Is now you can add in inverted indices. So that really helps with full text search. We're looking for a keyword within a set of unstructured logs. We now have support for inverted indices. So that's an experimental mode as well. You can import, export dashboards, and et cetera, et cetera. So there's a whole lot more, and you could definitely keep track of our blog and our release notes to find out more information about all that our team has been up to. And then lastly, I want to talk a bit about what is ahead. So there's a ton of features that we're really excited about. One of the big ones that we hear a lot is about PromQL, so supporting PromQL queries on top of ClickHouse, and that is coming. In fact, a lot of that work has already been happening in the open source side of things. It's still early stages, of course, but that's the team's kind of hard at work at introducing PromQL support. So soon you can actually write your Prometheus metrics directly into ClickHouse using the new time series engine, and then query it out using PromQL like you would with any other PromQL compatible database. And also really excitingly, working towards kind of byte for byte compatibility with existing Prometheus servers as well as part of that. The other bit is also ClickStack Cloud, so kind of like fully managed observability experience on top of ClickHouse Cloud, kind of going beyond the ease of use for the integration to allow kind of a hosted ingestion and other bits as well. Inverted index, as I mentioned, is currently an experimental, and that's going to continue to mature and roll out over time. So really excited to be supporting that as it heads towards GA. Things around observability notebooks, so providing kind of new user experiences to be able to not only search and chart your data, but also create a whole investigation workflow and be able to share with your colleagues how you narrow down a specific issue over time within the UI. So not only showing a chart, but also showing how you got to that point to kind of fully explain and also allow folks that are exploring, investigating to also more easily branch out and experiment with different branches of hypotheses and charts that they want to build. Other things around service maps, really popular request to not only take your trace information and do analysis on the observability level, but also have a more service level view, be able to understand if there's errors, what errors are happening between what services, at what error rates, and what traffic's increasing and whatnot. Things like Terraform Provider as well to help config ClickStack programmatically, and a whole lot more beyond that. Otherwise, a lot of this information you can get on our website today at clickhouse.com/O11Y, what you see on the screen. That'll land you into the observability use case page within ClickHouse. We can see how you could get started, all the features, the documentation, and more for ClickHouse and observability. Awesome. So with that, maybe we can turn it over to questions. I don't know, Johnny, if there's any questions I can help answer them.
Yes. Hey, Mike, that was great. Thank you very much for that. That was a great intro. Lots of questions, actually. Quite a few got answered, but I did want to leave some open for you as well, if that's okay. The main one, which I thought was quite interesting, I know it was kind of answered live, but may I know the value? Sorry, let me repeat that. May I know the value ClickStack is going to add in my observability? And I think that's an open-ended question in terms of the ClickHouse value itself. When we talk about compression, deduplication, highly concurrent queries, just the speed and effectiveness of ClickHouse over other databases, I think is a value that is quite useful. But also from the ClickStack HyperDX side, I think you mentioned some of that as well. But is there anything else you wanted to add to that?
Yeah, I mean, I think no, I think you nailed on the head, right? Like ClickHouse as itself, there's a reason why a lot of these large, fast-growing enterprises or startups are using ClickHouse. That's because it scales incredibly well, handles high volumes. It's relatively, easy to kind of maintain and scale with your workloads as well. and also incredibly flexible. Those logs aren't being locked into a really simple interface. You're able to query it complete with SQL. There's some really complex questions our SR team is able to answer because we use ClickHouse for observability, and I think we've written about it as well. And you guys should definitely take a look at some of the use cases there. As for ClickStack on top, it's really easy to get started with. The easiest way to get started with ClickHouse for observability. And of course, as I mentioned, there's a ton of optimizations being made specifically for ClickHouse. I've only mentioned a few here, but there's a ton of detail and polish being put into making sure that it's the best experience on top of ClickHouse, and it's more optimized. It's going to be more efficient, faster, and the UX kind of more built for the ClickHouse way of doing observability.
Yeah, that's that's great, Mike. Thank you very much. A lot of that you mentioned in the call, but absolutely, ClickHouse being a very fast, effective database, OLAP database supporting highly concurrent queries is definitely a key differentiator between other sort of platforms out there. Also, going through the questions, there's quite a bit that you did answer. I see one about the service map. So there was a really good roadmap slide that you just did earlier on. I think that was great. So definitely service maps is part of the roadmap, which is going to be great. And yeah, this one that just came in now, it's quite good as well. We already have a vanilla OTel collector collecting telemetry data and pushing it into ClickHouse. Can we leverage these new tools for the OpenTelemetry collector versus the HyperDX standard gateway that you have?
Absolutely. No, that's a really good question. So the answer is yes, you can definitely leverage ClickHouse, or sorry, ClickStack is really made to be schema agnostic. So the UI that I showed earlier is using the default OTel schema that will come with the existing ClickHouse exporter. But we have users who use vector, so completely not OTel ecosystem at all. Folks that are importing data via S3, custom logs and metrics they have via their own kind of like specific application pipeline. It's really flexible to any of those use cases. I didn't show it today, but there is a source configuration setting that helps you define how do you map between observability concepts like timestamp and service name and level, if they're available, to the columns or SQL expressions within ClickHouse. So short answer, yes. Long answer, you could check out the docs as well. And there's quite a bit of configuration and knobs available for exactly that use case.
Awesome. Thank you, Mike. So one question I have, I think, I'm not sure if it's asked, but currently the schemas are related to HyperDX version 1, which is everything through the HyperDX collector. But with the sort of future versions, there'll be more schemas available. Is that going to be right, where it's not just going to be based on OpenTelemetry?
Yeah, absolutely. So right now, if they're referring to HyperDX V1 as the product, so that one definitely had a really locked down schema and a very strong opinion in terms of what the data need to be look like. For V2, and a lot of the effort has been making that more flexible. So we know a lot of teams have a specific preference for how that schema is structured for using a different pipeline that doesn't use the OTel schema. So you can use any schema today with HyperDX as part of the V2 release. So absolutely, it's kind of, you could use it with any schema and, any kind of pipeline you're interested in.
Awesome. Thank you, Mike. Because yeah, there was lots of questions on the JSON type in related to that as well. So you just answered that. You can use the JSON type with any types of schemas as well, which is great. I'll take this other one. So any comparisons between ClickHouse and StarRocks? Yes, there is. Well, not just StarRocks, but there is ClickHouse, ClickBench, I think it is. I'll share the website where there's lots of comparisons between obviously StarRocks and other sort of comparisons there as well when it comes to performance testing, JSON type and other types of comparisons there. But happy to share more info on that. But absolutely look at ClickHouse benchmark. I think I've got to find the link. Let me share that as well. We'll probably take, unless you see anything else here, there's a couple of more questions, but we can answer some of these live. What are the operational overheads? Does it require a dedicated team to maintain HyperDX, ClickStack, and OpenTelemetry?
Yeah, absolutely. So I would say that it certainly depends a bit on the scale. At a certain scale, there's going to be a requirement where you're going to have some people need to think about petabytes or tens or hundreds of petabytes effectively. You're going to hit a scale where you're going to need to think about it. But that being said, for the vast majority of people, ClickHouse is really easy to kind of set up, especially within cloud, right? A lot of that headache is managed for you. The difficult part is making a durable, petabyte scale database kind of highly reliable and backed up, and able to scale elastically on demand. And ClickHouse Cloud has that available for you. And in that case, really the bits that are left is the HyperDX UI, which is really all the hard work is being done by ClickHouse. The UI itself is really trying to kind of enable visualizations and use cases and user management and other metadata on top of ClickHouse. So that's not really something that needs to be scaled a ton. And then, of course, there's the telemetry collectors. Um, that being said, you're going to have agents kind of run no matter what use case. And typically, those are a lot easier to run. They're a lot stateless. You kind of spin them up and down, and there's a variety of architecture to deploy them. I would say a ClickHouse tends to be, obviously a stateful database and a high scale one as well. But within ClickHouse Cloud, that makes it really easy to work with.
Great. Thank you, Mike. Great answer. The next, maybe we'll take two more. The next one I wanted to touch on is, I think I've got this. I think it's to do with joins. How to join two streams in ClickHouse. So if any change in any table, not only the change on the left side table like Flink. Yeah, so I think this question is related to, in ClickHouse specifically, the right-hand table, if you're running a materialized view, doesn't trigger in a particular join. But yeah, how would you do joins in ClickStack for observability workloads?
Yeah, absolutely. So I think it really depends on what the join is being used for. I would say that it really depends on whether you're going to have that materialized on demand. And there's a really wide variety of materializing as well, right? Not only kind of like the traditional like insert materialized views that ClickHouse is used to, there's also refreshable materialized views. There's really a wide gamut of kind of enriching your data these days. But that would be kind of the suggestion is to have that available in a view somehow. And then as far as like the HyperDX UI is concerned, it's really querying a table under the hood. So whether that's being created via a regular materialized view, a refreshable materialized view, via I believe like a alias table engine or whatnot as well, all those are kind of possible.
Okay, yeah, so a lot of it's to do with ClickHouse as well and being able to run those materialized views. So you can do that and then query the end table in ClickStack as well, or HyperDX, correct. That's great. There was one more question that I wanted to touch on. It may need a little bit of screen sharing, Mike, if that's okay, but it was to do with the OpenTelemetry demo and just about session replays. Could you maybe just run through that part again around how the session replays work in the beginning? You kind of explained it, but I'm not sure if you
Yeah,
went through the demo.
absolutely. So one thing, if my computer can do this correctly, so let me just try to pull up the demo really quick so I could share it with you guys. So yeah, this should work. Oh, that did not do what I want. Sorry, apologies. One moment. Okay, gotta reopen the demo. So hopefully this will work this time. So one thing to note is that you can go to play-clickstack.clickhouse.com. That's where this demo is currently being hosted. It has a few different demo data sets available for it that you can play around with. And that's kind of where this demo is being driven from. And here we have a variety of session replays. So you're able to kind of quickly look up, if you have like a specific user email, all these emails are not real. So it's kind of difficult to actually search up an email here, but you could search by user email. You could click into any given session and you actually could take a look at what was happening on that page at a given time. Here, I don't think there's any errors, but if there was an error, like a 500, for example, you can actually, it'll usually pop up on the other tab, but here we could go and see all the events, go and see, a specific, for example, API call, and you actually drill into what was happening on the back end from any specific front end session. So if you're really used to, typically for application engineers, support engineers, this is super popular with. You have a case that a user reported hit some issue at a given point in time. You could actually trace it all the way back into the backend natively within ClickStack. So this is all powered by OpenTelemetry, ClickHouse, and the HyperDX UI.
Great, thank you, Mike. Great demo. We've got some really good questions. I don't know if we're going to get time to answer them all. Maybe we might have to take a list of these and respond back afterwards as well. But that was a great demo. Maybe we'll take two more. That's okay.
Yeah, absolutely.
In the
Let's
interest
do
of
it.
time. So I'm just trying to pick. There's some really good ones here.
Yeah, I can
I'm
see
gonna.
it.
Oh, I think I'll select this one from Jamie, I think it's Jamie L. This is a good question. Is there a tagging feature available, and is it possible to reuse tags that are already created in like Azure or AWS?
Okay, yeah. Is there a tagging feature available? So you can, so I guess it depends on how you're defining tagging. So both you can tag things like dashboards and searches within the UI. So if your user, your team creates searches and whatnot, or dashboards, you want to organize them via tags, you can. The other question might be more of like, how do you tag telemetry, or how are telemetry tagged with resources? Might be one way to view it as well. In which case, it really depends on which platform you're using. So for example, in Kubernetes, if you have your pods or services tagged with a specific label, you can actually configure it to pull the Kubernetes label into the resource attributes. So you could search by a specific Kubernetes label. That's just a configuration on top of OpenTelemetry. So a few different ways. I guess depending on how that question was really structured, a few different ways of accomplishing it, but the answer should be yes for hopefully both those
Yeah,
interpretations.
yeah, it's a great question. You can also, I just realized this recently, you can also create description columns in ClickHouse, and then, well, descriptions on a particular column, and you can search against that description as a tag as well from the system tables, which is quite cool. So that's something that you can leverage in ClickHouse for tagging data. Awesome. So, kind of two questions. I think this is related to wide events. So, how does ClickHouse handle wide events? Um,
Yeah,
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 wide
absolutely. So
tables.
yeah, white events there's a few different ways you can do it. Let's just say you're going to emit white events via logs today within like, OTel structured events. You can always, of course, add them as log attributes to a specific log message. And if you're within the OpenTelemetry ecosystem, they'll either put it into the map data type that we showed earlier. So it's going to put it into a column that's specialized around key value. And that will, handle really high cardinality. We have people with like hundreds of thousands or even more kind of properties that are being put into these specific columns, and it scales incredibly well for the use case. Or it might be put in the JSON data type. I talked about that earlier. It's able to intelligently kind of pick out which properties to optimize and which ones aren't. Because you have wide events, you probably have some events or some properties that are going to be super common. Maybe, for example, pod ID or user email or user ID or whatnot that you'll use for searching and aggregating very often. And there might be a lot of other properties that are going to be a lot more rare to use, and those will kind of get optimized away so they don't, take a lot of overhead, which is kind of what plagues some of the other systems when they try to take on wide events without that kind of optimization.
Great, thank you, Mike. I think the last question, because I think I have to wrap this up pretty soon as well. And there's still quite a few questions, 20 to go. We might have to follow up on that later as well, unless you tell me otherwise. But I do have one more question that I'm interested in as well. Does ClickStack support multi-tenancy? And if not, is there any plan to support that?
Yeah, so I think that depends on multi-tenancy from which perspective. So I'll say that within open source, multi-tenancy is specifically one of the features that we suspect if you're looking for it, you're probably a better fit for the commercial solutions that we have with ClickStack today. Within cloud, of course, there is multi-tenancy. You can set up multiple instances across multiple teams. You can switch across them really easily as well. So within the cloud integration and what's available in ClickHouse Cloud, the answer is yes. With open source, it's specifically an item that we're not kind of including in the open source version.
Okay, perfect. So when you go to ClickStack and you can select the different types of databases, is that going to be available in the cloud as well?
So which databases in this case? Like connecting to different
Yes.
services, I guess.
Yes, correct.
Yeah, so within the cloud, you're able to switch between different services directly. So what we have here, where it shows a local mode because it's a local mode demo, it actually is a switcher. So you actually switch
Yep.
between the different services you have natively.
Yep. Awesome. Okay, great. Well, thank you, Mike. We keep getting more questions. I might have to wrap this up, and we've got a lot of responses to get back to as well. But if there's anything else, happy to go through or hand back to you, Mike.
Yeah, absolutely. Really appreciate everyone coming out today. We'll try to kind of be able to answer some of the questions we weren't able to get to today. Really thankful for everyone for answering all these questions and staying super engaged. Please feel free to, send kind of any questions in the future as well towards us as well. And you could kind of visit the webpage that I kind of showed earlier, so you could learn a little bit more about what we're building. And of course, you could always reach out to a ClickHouse team member if you have more questions, or on our Slack as well. Me and a lot of the engineers working on the product are always around there to help answer any questions or help get started. All right. With that, I think we're all done for the day. Thanks, everyone. Thanks, everyone, for coming.